Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. So, how are all of you today? I do hope that all of you recall in good condition, and please take care of yourself while the pandemic of COVID-19 is still how can I say this? Something that haunted all of us, okay, with the cases reach up to 20 cases of cases every day. And I do hope all of you just be patient, stay at home, and help your family, and don't forget with our lecture. Okay. So before we continue, I do hope that all of you willing to help me to join to strengthen my channel, my lecture channels here by click on the button of subscribe, like, share, and the bell button here. The bell button. Okay, I'm sorry, I have no idea how the other YouTubers come up with the sign of all this, so I just sketch it, and I do hope all of you know what to do to support my channel. Okay, so in these videos we are going to discuss come up again and again, so I have no idea what's wrong with this pen. Okay, so we're going to look into the sign of what we call absolute values. Okay, absolute values in the simple ways to explain to you whatever value that we have inside these two poles, or we call the absolute value sign here, it will always positive. That's it. Okay. So modulus absolute values of negative a equal to a. So in physics, it's just like this. When somebody stand on one point here, and if he move 3 units to the right, or he move 3 units to the left, okay, the distance from this point to, and also this point to another point here, let's say come up with A and B from O. The distance from O to A are equal to O to B, which is 3 units. But what makes a difference here now? When we move to the right, we assume that it's a positive, and when we move to the left, we assume which is negative. That's all. So negative and positive is just like we call the direction to the left or right. But then the unit or the value or the distance are all still equal. We call equal, still positive 3 units. We call 3 units. Okay. So this is it. Absolute values of ax plus b equal to cx plus d. So we are going to solve the absolute values equation of this form here and these forms. So definition of absolute values represent the distance of a point on a number line from the origin point. Okay, I mentioned to all of you just now, from O to A with A unit, from O to negative A is also A unit. The difference is whether we move to the right, which is positive, or move to the left, negative. Examples for this one here, modulus of 3 equal to 3 units to the right, okay, and negative 2 equal to 2 units to the left, okay. So these are things that you need to remember. Modulus of A equal to A and negative A. For this one here, if A is greater than or equal to 0, and negative A if A is less than 0. And of course, just like this one here, negative 2 is less than 0 and 3 is greater than 0. Okay, so modulus A is also defined as a square root of A squared. Write the following without this absolute value symbol here. For this one, it is 2x minus 1 when x greater than or equal to 1 over 2, and negative of 2x minus 1 for x less than 1 over 2. Okay, and what about this one here now? It is 1 minus x. Okay, so therefore 1 minus x greater than or equal to 0 and negative 1 minus x for 1 minus x that less than 0. Okay, so for this one, actually that before we reach at this point, actually that I suppose we write that this one has as 2x minus 1 greater than or equal to 0, and this one here negative of 2x minus 1 which is less than 0. Then from here we get this one here, and this we got this one here. So what about this? 1 minus x and negative 1 minus x, and here which is x less than equal to 1 and x greater than 1. Okay, so I explained to you just now all of this. I don't realize that there's a page that explaining all this one here and this one here. So the properties of absolute values. Okay, I'm not going to explain everything. You just you go look by yourself. Try to remember. Okay. Modulus of A plus B is not equal to modulus of A plus modulus of B, and is both for plus and minus. Okay, equations involving absolute values. Modulus of A, modulus of x equal to A greater than 0 represent the distance from x from origin is a unit. Okay, so therefore x modulus of absolute values of x equal to A is equivalent to x equal to A or x equal to negative A. And I mentioned just now, negative represent the direction to the left. So what about this one here now? Okay. So for this one, this is an equal sign. So with equal sign, this is an equation, not inequalities. Equal. So this one equal to one value of 11. Okay. So by the way, modulus of 3x minus 4 equal to 3x minus 4 for x greater than equal to 4 over 3, or negative 3x minus 4 for x less than 4 over 3. Okay, so we got two definitions here. Okay, since that we have two definitions here, so then we take the first definition. Okay, to definition of, okay, for example here the first one, 3x minus 4. Okay, sorry, 3x minus 4 equal to 11, or here negative 3x minus 4 equal to 11. Okay, so then 3x negative 4 here become positive, so 11 plus 4 equal to 15, and x equal to 15 divided by 3 equal to 5. And this one here is either you expand this negative with 3x minus 4, or you bring this negative to the left side. Okay, both are acceptable. Okay, negative 3x plus 4. Negative times this one here, negative times negative 4, positive 4 equal to 11. So negative 3x equal to 11 minus 4, 7. Then x equal to 7 over negative 7 over 3. Okay. So then the solution set is negative 7 over 3 and 5. Okay, now again, just imagine that these two have one definition, one is positive and one is negative. So negative we bring up to the 3 here. What I'm trying to say is, it's just like example here, x plus 1 divided by 5 minus 2x equal to 3, or x plus 1 divided by 5 minus 2x. Actually that is negative here, so bring negative to the 3 here equal to negative 3. Okay, so now 3, since there is an equation here, so we make what we call come up with cross multiplication. So x plus 1 equal to 3, 5 minus 2x. And also here x plus 1 equal to negative 3 times 5 minus 2x. Okay, so this is 3 times 5, 15. 3 times negative 3 equal to negative 6x. Negative 6 bring here become positive. So x plus 6x, 7x. 1 bring here become negative. So 15 minus 1 equal to 14. And x equal to 14 divided by 7, 2. And this one here, negative 3 times 5, negative 15. Negative 3 times negative 2, positive 6x. So then 6x positive here become negative. So x minus 6x, negative 5x. And 1 will here become negative. So negative 15 minus 1, negative 16. Negative 16. So then x equal to 16 over 5. Okay. So then the solution set is 2 and 16 over 5. Okay. So the following equation, give the answer in set notation. Okay, for this one here now. So then, again, for this, it defined as a 2x minus 1 for x greater than or equal to 1 over 2 and negative 2x minus 1 for x less than 1 over 2. Take the first definition, 2x minus 1 equal to 4x minus 3, or negative 2x minus 1, so negative bring up to the side, so 2x minus 1 equal to negative 4x minus 3. Okay, so 4x here become negative, so 2x minus 4x, negative 2x. Negative 1, bring to the side become positive, so negative 3 plus 1, negative 2, then x equal to 1. Then, what about here now? 2x minus 1, negative times 4x, negative 4x, negative times negative 3, positive 3. So, negative 4x bring to the side, left side become positive, so 2x plus 4x, 6x. Negative 1 will become positive, so 3 plus 1 equal to 4, then x equal to 2 over 3. Okay. Okay, to see whether these two values of x, satisfy the equation, let's try modulus of 2 times 1, x equal to 1, 2 times 1 minus 1, equal to 4 times 1 minus 3. 2 times 1 equal to 2, 2 minus 1 equal to 1, equal to 4 minus 3 equal to 1, Yes, that's it. Okay. And then modulus of 2 times 2 over 3 minus 1 equal to 4 times 2 over 3 minus 3. 2 times 2 equal to 4. 4 over 3. 4 over 3 minus 1. 1 or 3 over 3. 4 minus 3 equal to 1 over 3 equal to 4 times 2 equal to an 8. 8 over 3. 3 times 3 equal to 9 over 3. Okay. 8 over 3 minus 9 over 3. 8. Okay. 4x minus, okay, no, 2x minus 1, 4x minus 3. Okay, so 4 times 2 equal to 8, 8 over 3 minus 3. Change this in a form we call a fraction, or with the denominator of 3 here. So 3 times 3 equal to 9. 9 divided by 3 equal to 3. So 8 minus 9 equal to negative 1 over 3. 1 over 3 is positive and this one is negative, so they are not equal. So the solution set is x equal to 1. Okay. So method of squaring both sides. In this, we all agreed to expose to all of you with one method of squaring both sides, even though might be there's another method. I can't remember whether it's the method or not for this one. Never mind. Okay, don't make ourselves confused. We can refer to the notes here now. Method of squaring both sides only if we have modulus on both sides, 1 and 2. Okay, so squaring both sides here, so then I come up with 2x minus 1 square equal to 4x minus 3 square. Okay, so expand of this one here, 2x minus 1, 2x multiplied with 2x minus 1, 2x multiplied with 2x, 4x squared. 2x multiplied with negative 1 minus 2x. Another minus 2x minus 4x. Negative 1 multiplied with negative 1, positive 1. Okay, I'll explain separately here. 2x minus 1 multiplied with 2x minus 1. So you may refer to this to understood the process on the other side. Okay, 2x times 2x, 4x squared. 2x times negative 1 minus 2x, negative 1 times 2x minus 2x, negative 1 times negative 1, positive 1. So then, 4x squared minus 4x plus 1. Okay, same goes to this one here. 4x times 4x, 16x squared. 4x times negative 3 minus 12x. Another negative 12x, negative 24x. Negative 3 times negative 3, positive 9. Okay, so then just imagine that if we bring all this to the other side, 4x squared bring to the side become negative. So 16x squared minus 4x squared, 16 minus 4, 12x squared. Negative 24 plus 4, negative 20x. 9 minus 1 equal to 8, equal to 0. Okay, so then we factorize 12, 20 and 4. We have common, all can divide by 4. So then 4, 3x squared minus 5x plus 2. 4 times 3 equal to 12, 4 times negative 5, negative 20, 4 times 2 equal to 8. Okay, so then here we factorize, we call the function inside, which is quadratic. Okay, Okay, it's whether you write it 4 or not here. It won't be count when we compare the two linear function here. That one. So we got 3x minus 2 and x minus 1. So we got these two linear factor. Okay, so then from here we come up with x equal to 2 over 3 and x equal to 1. So then the solution set x equal to 2 over 3 and 1. Okay, you may check both of x satisfied of the equation of this or not. Okay. And now, this is quadratic. Modulus absolute values of quadratic equal to 3. It is x squared minus 5x plus 3 equal to 3, or x squared minus 5x plus 3 equal to negative 3. Okay, we solve one side one by one here. We get x squared minus 5x. 3 will become negative, so 3 minus 3 equal to 0. So then x minus 5 equal to 0. Okay, so on this side, we come up with the first conclusion where x equal to 0 and x equal to 5. Okay, and this one here now, x squared minus 5x negative 3 brings up become positive, so 3 plus 3 equal to 6. And factorize this. It is x minus 2 and x minus 3. Let's double check. X times x, x squared. X times negative 3, negative 3x. Negative 2 times x, negative 2x. Negative 3x minus 2x, negative 5x. Negative 2 times negative 3 equal to 6. So then the solution set here is x equal to 2 or x equal to 3. Okay. So then we could take all these 1, 2, 3, and 4. So then the solution set is 0, 2, 3, 5. There you go. Absolute values in inequalities. So just now we're talking about absolute values with equation. Now it's time for absolute values inequalities. Okay, the distance of x and the origin is less than a. So when we have this kind of line, it shows that it does not include negative a and does not include a, but it's less than and less greater than here. Okay. Okay. So when we have x less than, we call greater than a or less than a, okay, from this statement, we can define into this statement or this statement. Please remember this is either absolute values of x less than a or less than or equal to a. Okay, so we can define into this form and this form. So if I have modulus of x less than or equal to a, then I can define as an x greater than and less than negative a and a, or in this form, x greater than or equal to less than or equal to negative a and x less than or equal to a. Okay. Okay. So for modulus of x less than a, so please remember we can define it in this form or this form. Okay. But when it comes to modulus of function of x or fx greater than a, okay, is either here or here. Okay, just imagine that this is Kedah, this is Thailand, and this is Kelantan. Okay, you are allowed to stay only in Malaysia only. So, which of this in Malaysia? Yes, of course we know is Kedah and Kelantan, or Kedah or Kelantan, not Thailand. So it means that you can build a home, your house, either in Kedah or Kelantan, here or here. You get it? Greater than, then we just imagine that it's separate. Now we call the area is separated, is either here or here. There you go. X less than negative a or x greater than a. Same goes to modulus of x greater than or equal to a. So we can only write this one as an x less than or equal to negative a or x greater than or equal to a. Okay, these are separate cases, but for greater than or equal, and this one is for greater than, like this one here. Okay, now, here. I mentioned to all of you, explained to all of you just now, so we can put them all in this table, and you can see clearly what I'm trying to mention to you just now. Okay, 2x minus 3, 2x plus 3 less than 5. Plus, for this question, there are actually two options. Okay, I'll show you both of the method of solving this. You can choose either method that you prefer with. Okay, so option number one. Okay, option number one. From this statement, modulus of 2x plus 3 less than 5. You still remember what we call this? We call the sign that we're going to use then for this one here. Where is it? Okay. Yep. Yeah. This one. Okay. From modulus of x less than a, look at, refer to this one here now. Modulus of x less than a, then it is x less than a and x greater than negative a, and also, okay, this one here, x in between negative a and a. So we are referring to this time now. Okay, that one what we call solve this as an option number 2, when we separate into two parts with term of n in middle. Right now, first option number 1 or method number 1, 2x plus 3 less than 5 greater than negative 5. Okay, so 2x plus 3 minus 3. So, okay, the reason I come up with minus 3 here, we would like to eliminate this. So then, we also come up with 5 minus 3 here, and negative 5 minus 3. Okay, so then 2x, 5 minus 3 equal to 2, negative 5 minus 3, negative 8. Okay, not all the time that we can use this. Sometimes it makes, there's what we call, the cases that make us confused. Okay, but since that this is 2x, 2 is positive, so we divide by 2 here, divide by 2, divide by positive values, it won't change the sign of this. So divide by the 2, x greater than 2 divided by 2 equal to 1, and negative 8 divided by 2, negative 4. So x lies in between negative 4 and 1. okay, which is negative 4 until 1. Okay, method number 1, idea or option, we call it idea or suggested solution for number 1. Or you may also solve this question like this. And this one here, from this statement, we take the first half here of 2x plus 3 greater than negative 5. 2x plus 3 greater than negative 5. And 2x plus 3 less than 5. Okay, so let's try. 3 bring here become bring to the side become negative, so negative 5 minus 3, negative 8, and x greater than negative 8 divided by 2, negative 4. This one here, 3 bring to the side become negative, so 5 minus 3 equal to 2, then x less than 1. Okay, with this we call solution on the left side and solution on the other side. We bring them together, negative 4 and 1. X greater than negative 4. And x less than 1. So we have that we found out there is a term of n here. Okay, this is method number 1. It's a separate. I show you both of the option of the how solving this question. So you may choose either we call method number 1 or method number 2, that's easy for you to understand. It's all up to you then. Okay, when it comes to the term of n, so we try to find out where they intersect each other. It is here. So then the solution set here is negative 4, 1 until 1. So compare, we get 1 clear, we call 1 correct answer. Okay, now is greater than or equal. So greater than or equal, we get negative 4 and 4. So then 3x minus 1 less than negative 4 and 3x minus 1 greater than 4. Okay, so then the first one here, 3x minus 1 greater than or equal to 4, or 3x minus 1 less than or equal to negative 4. 3x minus 1 less than negative 4, or 3x minus 1 greater than 4. Okay, so then 3x negative 1 right here become positive, so 4 plus 1 equal to 5, and x greater than equal to 5 over 3. And this one here, negative 1, bring here become positive, so negative 4 plus 1, negative 3, then x divided by 3, positive value, it won't change the sign of this, so it remain less than equal to negative 3 divided by 3, negative 1. Okay, so then x less than or equal to negative 1, negative 1 and 5 over 3, greater than or equal, and less than or equal. Okay, we have the term of O in the middle here. Okay, so if we have a term of n, so we try to figure out where do these two solution align of this. Okay, this one represent this and this represent this. Where do they intersect each other? If we have no n or O, then we are playing with the sign of positive and negative. But right now, it's not an and, but it's or here. So or means we're taking both all the solution here or here. Okay, so the final answer here is negative infinity until negative 1 union 5/3 to positive infinity. Okay. Solve the given inequalities. Okay. Okay, what about this one here now? It is modulus of 3 minus x. Okay, it's either 3 minus x for 3 minus x greater than equal to 0 and negative 3 minus x for 3 minus x which is less than 0. Okay, for the first one here, 3 minus x. Less than. Okay, the first definition here, 3 minus x less than 2x plus 9 and 3 minus x greater than negative 2x plus 9. Okay, because one is negative here, so we bring up negative to the side, so direction change. Okay, so then negative x, negative, okay, 2x bring to the side become negative, so negative x minus 2x, negative 3x. 9 minus 3 equal to 6. Divide by negative 3 left and right. Divide by negative 3 and negative 3. So direction change to x greater than 6 divided by negative 3 equal to negative 2. Okay. 3 minus x greater than negative 2x minus 9. Okay, negative 2x bring to the side become positive, so negative x plus 2x. When we bring this to the left side become positive here, negative x plus 2x, x. And negative 9, 3, positive to bring to the side become negative. So negative 9 minus 3, negative 12. Okay, so solution of set number 1 and solution of set number 2. Okay, bring these two to here. Okay, we got negative 12 and negative 2. First is x less than negative 2 here. And for this one, x less than negative 12. So, with the term of n, we are going to find out where do we call these two lines intersect each other. It's not here, but they intersect in this section here. So then, the solution set is from negative to positive infinity. Okay. Okay, now, modulus of 4x plus 1 greater than. Greater than, so then first is 4x plus 1 greater than 2x minus 5 or, okay, 4x plus 1 less than negative 2x minus 5. Okay, 2x positive bring to the side become negative, so 4x minus 2x, 2x. 1 positive bring to the side become negative, so negative 5 minus 1, negative 6. X greater than negative 6 divided by 2, which is negative 3. 4x plus 1 less than negative times 2x minus 2x, negative times negative 5, positive 5. Negative 2x bring to the side become positive, so 4x plus 2x, 6x. 1 bring to the right side, become negative. So 5 minus 1 equal to 4. Then x less than 2 over 3. Okay, so this is solution number 1 and this solution number 2. We put them on one number line here. Okay, first one here is x greater than negative 3. Negative 3x greater than. And x less than 2 over 3. X less than 2 over 3. Okay, now this is term of all. All means all. Okay, just now in the question of all, when we go one of direction, we go to the left and one direction to the right, we taking them all. Okay, right now is either intersect or not. Okay, whether intersect like this or not intersect at all like this and this, we are taking them all. Okay, meaning all of this is the solution set of the answer of the question. So that the solution set here is from negative infinity to positive infinity. Okay, so for this one here now, when there are two absolute values left and right, okay, we don't have to waste so much time on to find out whether it's we call greater than or less than, come up with two equations. No, for this one we can straightly come up with squaring both sides. Okay, x plus 3 here. X minus 1 square greater than or equal to x plus 3 square. So expand it one by one. 3x times 3x, 9x squared. 3x times negative 1 minus 3x, another negative 3x, so negative 6x. Negative 1 times negative 1 plus 1. Okay, x times x, x squared. X times 3, 3x, another 3x, another 3x, come out with 6x. And 3 times 3 equal to 9. So then, bring this to the left side. So, all is positive, so when brought to the left side, it becomes negative 9x squared minus x squared, 8x squared. Negative 6x minus 6x, negative 12x. 1 minus 9 equal to 8, or not less than, greater than. Okay, greater than or equal to 0. Okay, so factorize with a 4 here. So we got 2x squared minus 3x minus 2 greater than equal to 0, and factorize this 4. We may ignore it or we just write down it's okay. Divide by 4, divide by 4. Yes, it's 0 here, never mind. 4 divide by 4 on left side and divide by 4. So there's only quadratic left here. And this quadratic of 2x squared minus 3x minus 2, we factorize, then we get 2x plus 1 and x minus 2. Okay, so using graph, we assume these two are positive, is greater than 0. Okay, we assume or let 2x plus 1 greater than equal to 0 and x minus 2 greater than equal to 0. Okay, again, if this sign, okay, for this sign is greater than or equal, is either greater than or equal, or greater than only, or less than or equal, or less than only. No matter what sign that we have here, we just assume that these two factors are positive. Just assume that these two are positive. It has nothing to do with this one. Okay, assume it positive first, then x greater than or equal to negative 1 over 2 and x greater than or equal to 2. Okay, so then we got negative 1 over 2 and 2 here. Okay. So in this case, there is no term of n or o. There is no term of n or o. Okay. So it means that in this case, we are going to play with the sign of positive and negative. Okay. So multiply between these two factors or values here, negative multiplied with negative, positive. Negative multiplied with positive, negative. Positive multiplied with positive, positive. Okay. Final answers, okay, based on what is given here. Two linear factors, 2x plus 1 multiplied with x minus 2 greater than or equal. Greater than, okay, means that the numbers here must always positive, okay, because positive numbers, positive values is always greater than 0. So it is here and here. Okay, so the final answers in interval 4. Okay, it happened again. Okay, sorry, I have a problem with this one here. Okay, the final answer here for this one is from negative infinity until negative 1/2 union. Okay, union, not U, union, symbol of 2 to positive infinity. Okay. Okay. Now, this is a question. It's between fraction in modulus less than or greater than with a number of 1 here. Okay. So it is now x minus 3 divided by 2x plus 1 less than 1 and x minus 3 divided by 2x plus 1. Okay, we cannot simply... Okay, now we bring this to the left side, 1 to the side, x minus 3 divided by 2x plus 1. Okay, 1 become negative minus 1. So I straightly multiply and divide with the denominators of this here, 2x plus 1. So 2x plus 1 divided by 2x plus 1. Okay, less than 0. So now, negative 1 times 2x. Okay. X minus 3, negative 1 times 2x minus 2x, negative 1 times 1 minus 1. Divide by 2x plus 1 less than 0. X minus 2x, negative x, negative 3 minus 1, negative 4. 2x plus 1 less than 0. So, the sign here is less than. For both of these linear factor, we just assume that let negative x minus 4 greater than 0, 2x plus 1 greater than 0. Okay, so then negative x greater than 4 and x less than negative 4, and here x greater than 1 will become negative 1 divided by 2, negative 1/2. Okay, so now it's between negative 4 and negative 1/2. It less than negative 4 and greater than 1 of negative half. Okay, for this side, do you find any term of n or o here? No. Okay, means that we are playing with a sign of positive and negative. So we have positive, negative, 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 positive. So then one value either positive or negative divided by another value is either positive or negative. So negative divided by positive, negative. Negative divided by negative, positive. Positive divided by negative, negative. And this one, which is less than 0. Okay, less than 0. So we're taking the negative area for this one here. So the solution set for this one is negative infinity until negative 4 and union negative 1 over 2 to positive infinity. Okay. And this one here now, x plus 3, x minus 3 divided by 2x plus 1 is greater than negative 1. So it means that here, 1 here with absolute values is between negative 1 and 1. It lies in between of x minus 3 divided by 2x plus 1. So this rational, we call rational function here, is greater than negative 1 and it is less than 1. Okay, less than 1 and greater than negative 1. Okay, so now bring this negative 1 to the side. X minus 3 divided by 2x plus 1. Negative 1 will become positive plus 1. So I straightly come up with this one multiplied with 2x plus 1 and divide by also 2x plus 1 to equalize the denominator, and it is greater than 0. So then x minus 3, 1 times 2x plus 2x, 1 times 1 equal to 1 divided by 2x plus 1 greater than 0. X plus 2x, 3x, negative 3 plus 1, negative 2, and 2x plus 1 greater than 0. Okay, now this is greater than 0 just now, and this is less than 0. But when we assume both of these linear, we assume these two, 3x minus 1 greater than 0 and 2x plus 1 greater than 0. Just assume that both are positive or greater than 0. Okay? And then it is now x greater than negative 1 will become positive, divided by 3, 1 over 3, and x greater than negative 1 over 2. Okay, and on this side, do you find any term of n or o here? No. Okay, I mean that on this side, not referring to this side only. Okay, there is no term of n or o. So again, just like this one here now, we are playing with a sign of positive and negative. Negative 1 over 2 and 1 over 3. Both are greater than. So we come up with positive, positive, negative, positive, negative, and negative. We come up with positive, negative, positive. And this rational function here is greater than 0. Greater than 0 means that the value is positive, right? This one here and here. So the solution set for case number 2 is negative infinity until negative 1 over 2 union 1 over 3 to positive infinity. Okay class, I found a mistake here. What I made, we call 3x minus 2 and 3x minus 1 is supposed to be 2 here. 2 and 2. And also 2 over 3 here, sorry. And here is 2 over 3. Okay, this is solution set for case number 1 here. And this is solution set for case number 2. We are going to bring these two solution set in one number line, and we finalize using this term of n. Okay, the first one here. Okay, case number 1, it is negative infinity until negative 4 union negative 1 over 2 to positive infinity. And case number 2. Okay, case number 2, it is negative infinity until negative 1 over 2 union 2 over 3 to positive infinity. Okay, for case number 1, I'll sketch with red ink, and for case number 2, I'll sketch the number line with purple ink. Okay, so now let's get back to this one here. Bring this on one number line. Okay, so we got negative 4 and negative half. Negative 4 and negative half. And this one here, negative half and 2 over 3. Okay, now, the first one, it is negative infinity until negative 4. Okay, and negative half to positive infinity. Then next is negative infinity until negative half. And this one here, 2 over 3 to positive infinity. So my question to all of you again, how are we going to finalize this answer? Finalize this. Look at this one here now. Between case number 1 and case number 2, there's term of n. Well, this term of n means that we are going to find where we call the line of purple and red intersect each other. So you can see clearly here now, it is intersect here and here. Am I right? Okay, so this is our final answer, which is negative infinity until negative 4 union 2 over 3 to positive infinity. Okay. This is supposedly for, we call the solution of 1 by 1. Okay. Okay, never mind. This all the, we call this all the final answer for example A. Okay, for question B, you may try yourself. Okay, if I separate this into two parts, and you got here, which is x plus 4 divided by 1 minus x less than or equal to negative 2, or x plus 4 divided by 1 minus x greater than or equal to 2. Okay, we try to simplify, and we call assume that we call both of the linear factors, numerator and denominator, and then we call the solution for case number 1, it is x greater than 1 and less than or equal to 6, and this one here, negative 2 over 3 less than or equal to x and less than 1. So bring these two, and your final answer should be in a recall as this one here, negative 2 over 3 1 union 1 to 6. Okay, you try this question, solve this question by yourself. Okay, and then from these two solution set on case number 1 and case number 2, we have here there is term of all here. When all means we're taking all the solution set on case number 1 and case number 2 and finalize here. You try by yourself. Okay, I do hope all of you will successfully get answers for this one here. Okay, the last example. Okay, for this one, it is, okay, for this one, less than or equal to 3, which is x squared minus 5x plus 3 less than or equal to 3 and greater than or equal to negative 3. So we get this in these two forms here, x squared minus 5x plus 3. Okay, the first one, which is greater than or equal to negative 3. And, okay, x squared minus 5x plus 3. Okay, this one, okay, this quadratic equation less than or equal to 3. Okay, so bring these 3, negative 3 to the side, become positive. So we got x squared minus 5x plus 6 greater than or equal to 0. And this one, 3 here become negative. Then x squared minus 5x. Okay, 3 minus 3 equal to 0 here. Okay, so for this one, factorize x minus 2 and x minus 3 greater than or equal to 0. So assume these two positive. Let x minus 2 greater than or equal to 0 and x minus 3 greater than or equal to 0. Then x greater than or equal to 2 and x greater than or equal to 3. Okay, so from the number line of these two, 2 and 3 both are greater than. Okay, there is no term of n here or all here. So we are playing with sign of positive and negative, positive, positive, negative, positive, and negative, negative. We come up with negative multiplied negative, positive, negative, and positive. So this inequalities, this multiplied with this one, x minus 2 multiplied with x minus 3 greater than or equal to 0, greater than, we're talking about positive value here and here. So the solution set is negative infinity until 2 union 3 to positive infinity. Okay, this one here now, factorize x minus 5, okay, x times x squared, x times negative 5, negative 5x less than or equal to 0. So let x greater than or equal to 0, x minus 5 greater than or equal to 0. Okay, assume both are greater than. So then, x greater than 0, okay, x greater than or equal to 5. So then, now again, from 0 until 5, greater than 0 and greater than 5. And again, on this side, you find that there is no term of n or o. We are not talking about this one. We're talking about on this side here. So again, we're playing with positive, positive, negative, positive, negative, and negative. So we got positive, negative, and positive. But then, these inequalities, x multiplied with x minus 5 less than or equal to 0. So less than, negative here. So the solution set for this case is 0 and 5. Okay, so now, 2 and 3 and 0 here. Okay. I'm going to sketch the line of case number 2, 0 until 5 with a red ink. Here until here. Before that, negative infinity until 2. Here. Okay. So, with this term of n, we're going to finalize, okay, we're going to finalize our answer. And from this term, we are going to find out where do these two lines of red and blue intersect each other. And of course, you can see clearly here now, it intersects here and here. So our final answer, which is, it is from 0 until 2, union 3 until 5. Okay, so that's all for today. So I do hope that with all examples, it makes all of you clear with the content of this topic and helps you to continue with your tutorial and pass your questions and helps you in the next task that will be given to you. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.